Hey everyone, welcome back to Geometry. This is Mr. Hagel, and today we are looking at 3.7 Equations of Lines in the Coordinate Plane. And the coordinate plane simply means that we're going to be looking at lines that are in the XY plane. And just a quick review, XY plane, the X-axis is your horizontal axis and your Y-axis is your vertical. So we can start with a quick warm-up, and this warm-up is algebra warm-up, so we're going to see if we can find the slope of a line passing through a couple of given points. So the first problem, we'll look at points -1, -4, and 2, 2, and our job is to find the slope of this line. Go ahead and pause the video and see if you can find the slope of that line. Alright, well hopefully you remembered that the slope of a line can be defined as the rise over the run. We can also put a formula with the slope, and the formula for the slope is m stands for the slope is equal to the change in y divided by the change in x's. When we're looking at a picture, we can look at the change in y or the change in x or the rise. So if we count that out, 1, 2, 3, 4, 5, 6 divided by 1, 2, 3. So that rise, 6, divided by the run of 3, gives us 6 over 3, which we can reduce to 2 over 1. And on the next slide, we'll look at how to use this formula when given points that are not in a picture. Alright, so let's review again. The slope of line M, is the ratio of vertical change to horizontal change. So ratio means it's going to be set up as a fraction. The slope of a line between 2 points, and here we can say point 1 has an x coordinate and a y coordinate, so we say x1, y1, and a second point, we call it x2, y2, is going to be the change in the y values, which is your rise, divided by the change in your run, which is your x values. So again, here's that formula, y2 minus y1 divided by x2 minus x1. If we look at a picture, over here we have a picture, a diagram. Here's our line, and we pick 82 points on that line, and the rise to get from one point to the next, so I have to go up 2 and then over 2. So again, the rise over the run. So we can look at this example. We're trying to find the slope of a line that passes through the points 4, 7 and -2, 10. So we start with filling in our equation. We have y2 minus y1, so that's the 10 minus 7, and that's going to be divided by the x2 minus x1. So now we can just simplify this. So we have 10 minus 7 is equal to 3, and then -2 minus 4 is going to give you a -6, and the last thing to do is to reduce this, and we get -1/2. Here we can look at slopes in general to get a sense of whether they are a positive slope or a negative slope. And when we do this, we always look at a line starting from a left point on the line and we move to the right. And if that line goes uphill, then that is what we call a positive slope. If, however, our line from the left side of the line goes downhill as we move to the right, then that is called a negative slope. A line that does not go uphill or downhill but does travel left to right, that is a zero slope. The rise is 0, the run you can calculate. And then a line that is vertical, notice we cannot even go left to right on this line. That is what is called an undefined slope. And here's a fun way to help you remember the slope, and this is what I call Mr. Slope Guy. With Mr. Slope Guy, we can look at his face features to help determine the slopes of lines. So if we look at his left eyebrow, notice that that is going uphill from left to right, and then it's got a plus, so that is a positive slope. His right eyebrow, however, is going downhill from left to right, and his eye is a negative sign, so that is a negative slope. And notice his mouth is a horizontal line with the little zeros for dimples, so that is a zero slope. A horizontal line is a zero slope. And last we have his nose, and notice his nose is made up of a vertical line, and then this is a letter U, which stands for the undefined slope for a vertical line. So if you're trying to remember which is a type of a slope you have, you can always refer to Mr. Slope Guy. Alright, next we're going to look at three different forms of lines or linear equations. We have, first of all, the slope-intercept form. The slope-intercept form. And the slope-intercept form says that y is equal to our slope times x plus b, and b is our y-intercept. So let's look at an equation that's written in slope-intercept form. Alright, so here's an equation. Y is equal to 1/2 x plus 4. In this equation, the 1/2 is your slope, and your y-intercept is at positive 4. And if we look at this equation in the coordinate plane, we start with our y-intercept of positive 4. So here's our positive 4 on the y-axis. And then we can use our slope of 1/2 to go up 1 over 2 and put another point. Up 1 over 2. We could also go down 1, left 2. And we would get this line right here. The next equation we have is what's called the point slope form. And the point slope form looks like this. It says y minus y1 is equal to m, your slope, times x minus x1. And in this case, x1, y1 is a coordinate, or is some point that's on the line. And it could be any point on the line, and m is your slope still. So we could write this equation for this line in point slope form, and I just decided to choose this point here, negative 2, 3. I could have chosen any point on the line, but we're going to write this equation for this line that has a slope of 1/2 and goes through the point negative 2, 3. So what I need to do is I need to substitute negative 2 in for x1 and 3 in for y1, and then our slope is going to be the 1/2. So substituting the values, then we have y minus 3, that's y1, is equal to our slope 1/2 times x minus x1, which is a negative 2. And since we have x minus negative 2, this equation is then going to become y minus 3 is equal to 1/2 x plus 2. And so there would be our equation written in point slope form. Alright, now we have what's called our standard form. Our standard form looks like this. We have ax plus by is equal to c, and in this case, a, b, and c are going to be integers. So let's take the same equation that we talked about at the beginning in slope-intercept form, and let's write this equation in standard form. So to write in standard form, we need to get the x's and the y's on the same side of the equation, and then the constant can be all by itself on the right side. So in this case, I need to subtract 1/2 x from both sides of the equation. And let's rewrite what we have now. So now we have minus 1/2 x plus y is equal to 4. And now we need to get rid of the fractions, because remember, we want only integers for a, b, and c. And right now we have this negative 1/2. So to do that, we're going to multiply by whatever the denominator is. So we have to multiply both sides of the equation by 2, because the denominator of 2, and we get negative x plus 2y is equal to 8. So now let's look at the three ways that we've written this equation. So up here we have the equation written in slope-intercept form. Here's the equation written in point-slope form, and here's the equation written in standard form. Okay, so here we need to write the equation of a line that goes through points 3, 5, and -2. And we can look at a picture as well, but we could do all of this without the picture. To do this, probably the easiest way is to write the equation first in point-slope form. Then, after we have it written in point-slope form, then we can change it to slope-intercept form. And finally, we can then change the equation to standard form. We need to start by finding the slope between the points 3, 5 and -2, 1. Using our slope formula, slope is equal to the y2 minus y1 divided by x2 minus x1, so I've substituted in my values. We get slope is equal to -6 over -5, which is just going to reduce to 6/5, and we're just going to leave that as a fraction. So now all we have to do is substitute into the point-slope form. Here is the point-slope form again, and now we substitute in for y1, our slope of 6/5, and our x1. And for x1, y1, we can choose any point that's on this line. Let's go ahead and choose the point 3, 5. So substituted in, we get y minus 5 is equal to 6/5 times x minus 3. And so here is our equation in point-slope form. Now let's write it in slope-intercept form. For slope-intercept form, we need to solve for y. So what we're going to do is we're going to distribute the 6/5 to the x minus 3. Then we will add 5 to both sides, and that'll have us in slope-intercept form. And distributing 6/5 times x, we get 6/5 x, and 6/5 times a -3 is going to be a -18/5. Now we're going to add 5 to both sides of the equation. And when we add 5 to a fraction of 18/5, I'm just going to convert 5 into an equivalent fraction of 25/5. That way I can combine these two fractions. And we get y is equal to 6/5 x plus 7/5. And the 7/5, we could rewrite that as 1 2/5, or 1.4. And looking at this way, y is equal to 6/5 x plus 1.4. We can even look, and our y-intercept, there's 1, and it would be 1.4, just slightly below 1.5. And that gives us our equation written in slope-intercept form. Either there, or either one of those are both written in slope-intercept form. Now to write it in standard form, let's start from our slope-intercept form here and rewrite it. And again, the strategy is to get the x's and y's on the same side of the equation and then to clear any fractions. So to do that, we're going to subtract 6/5 x from both sides of the equation. And we get -6/5 x plus y is equal to 7/5. Now we can clear the fractions by multiplying both sides of the equation by whatever denominator we have. So multiply both sides of the equation by 5. And we get -6x plus 5y is equal to 7. So now we have our equation for this line. Here's our line. We now have the equation written in 3 different forms. We have the point-slope form, we have the slope-intercept form, and we have standard form. These are all equivalent equations for this same line. So what I would like you to do now is to do the same thing as we did in the previous problem. Write the equation in point-slope form, then convert it to slope-intercept form, and finally write it in standard form.